Using linear models. So a scatter plot is just a graph that relates two sets of data as ordered pairs. So basically it's just plotting ordered pairs on a coordinate plane, and you've got a scatter plot. A correlation will tell us the strength of the relationship. So if you have an ordered pair, you have an X and a Y, and the correlation tells us the strength of the relationship between X and Y. Correlation is pretty much the association between the two. You have something called a causal relationship, and that's when one variable causes a change in the other. When you talk about the X and Y variables, the explanatory variable is the one that causes the change in the other. So that could be the X coordinate, and the response variable is the one that's affected. So usually when you put a number in for X, that affects Y. In terms of the relationship between the two values, you have a correlation that could be positive or negative. If you look at the graphs that they showed on the bottom of the screen, you can see that in the first one you have a strong negative correlation, and we say it's strong because the dots are plotted very closely to one another. You notice in the next one it's a weak negative correlation. Again, you can see that the dots are moving downward from left to right, so that would make it a negative correlation, but they're loosely scattered as compared to the first one, so that's more of a weak correlation. Then you have the one in the middle that shows no correlation at all, and there you can see you really can't make out whether the arrangement is moving up or down from left to right. They're pretty much scattered all over, so we don't see any kind of relationship between the X and the Y coordinates. The next one over shows a positive correlation because the pattern is moving up from left to right. It's weak again because the dots are kind of scattered about, not really closely plotted together. And then the last one shows a strong positive correlation because the dots are moving up from left to right, and they're pretty much tighter than in the previous one. So when they're grouped very closely together, you have a stronger correlation. Here they show a table that lists the average monthly temperatures and the electricity costs for a home in Texas in 2008. So the table has the values rounded to the nearest whole number. They want us to make a scatter plot, and they want us to describe the correlation. So the first thing we have to do, we're going to use our calculator for this. So the first thing we have to do is get all the numbers entered into the calculator. So let's call up the calculator here, and we want to get a list in a spreadsheet page. And in the first column, I'm going to call that X, and we'll enter all of the temperatures there. And in column B at the top, I'll call that Y, and we'll enter the values from the table. So the January average temperature was 61. February was 58. March 67. April 75. May 79. June 83. July was 84. August is 85. 81 for September. 76 for October. 65 for November, and December is 58. All right, so those are all the temperatures. And now we want to get the electricity bills in. So in January, the bill was $150. Try this again. $150. Next month was $139. March was $172. April 205, May 170, June 234, July 255, August 245, September 210, October 183, November 132, and December 110. Always make sure you hit enter after that very last one, and then go back and make sure that everything is entered correctly. Looks good. Okay, so they wanted us to make a scatter plot. So let's do that on the calculator. What we'll do is go back to the home screen and we'll do the data and statistics page. So double click on that and we have a scatter plot. So what we want to do is add our variables. So I'm going to click down here to add the X variable. I'm going to click here to the side to get the Y variable. And there's our scatter plot. So we took care of part one, where they want us to make a scatter plot. They want to know, how would we describe the correlation? So looking at the scatter plot, since the pattern is moving up from left to right, I would say that it's a positive correlation. And because the dots are plotted fairly close together, I would say it's a strong positive correlation. So that's how we can tell from the scatter plot what type of correlation it is. All right, the next problem shows us a table of the number of hours students spent online the day before a test and their scores on the test. So again, they want us to make a scatter plot, and how would we describe the correlation? So same idea. I would plot the ordered pairs from the table into the calculator, and then do the scatter plot and make the call on the correlation. So let's take a look at that. Let's get the calculator back. And what I'm going to do is delete these because we're done with the first problem. All right, so we'll call up another list and spreadsheet page. Again, we'll put X at the top. Okay, Y in the top of the second column. And we're ready to enter the data. So let's see, number of hours spent online. So I'm just going to enter them as they are in the table. Okay, so this is the number of hours spent online. In column B, we'll put the test scores in. Okay, again, remembering to hit enter after you put the last number in, go back, review, make sure everything is entered correctly. Looks good. So we're ready to do the scatter plot. So again, we're going to go back to the home screen. We're going to go to the data and statistics page, double click on that, and don't forget to add your variables for X and Y. And there you have your scatter plot. So now they want to know, how would you describe the correlation? So this one has a pattern that's going down from left to right. So it looks like we have a negative correlation. And again, since the dots are plotted pretty close together, we could say that it's a strong negative correlation. So basically, what they're saying here is that the more time spent online, the lower the test score. And that would be the correlation for this particular problem. All right, so here we have definition of a trend line. It's the line that approximates the relationship between the variables or data sets. You can use the trend line to make predictions from the data. Let's go back to the calculator where we had the problem with the test scores. The trend line you can get as well by hitting menu. We want to analyze, hit regression, and we want to show the linear mx plus b. All right, so the calculator inserts the trend line into the graph and also gives us an equation for that trend line. Okay, so that's used to see how strong the relationship is between the variables. And again, the closer the dots are to that line, the stronger the correlation. Okay, here the table shows the median home prices in Florida. So they want the equation of the trend line that models the relationship, and they want us to use that equation to predict the median home price in 2020. All right, so again, what we have to do is enter the ordered pairs from the table into the calculator, get our scatter plot, do the trend line, and then the equation will appear, and that will help us to do the prediction. So we'll go back to the calculator again, and I'm going to delete this problem. We're done with this one. And begin a new one. So list and spreadsheet page. Again, up on top of the first column, X. And Y for the second column. Okay, so X will represent the year, and Y will represent the median price. So we'll get the data in. So the first year is 1940. Try that again. 1940 and 1950. 1960. 1970. 1980. 1990. And the year 2000. Okay, then the prices, 23,100, 40,100, 58,100, 57,600, 89,300, 98,500, and 105,500. Okay, go back, review the data. Looks good. So we're ready for the scatter plot. So we're going to go back to the home screen, data and statistics page, add our variables, X and Y, and we have a scatter plot. We want to get the trend line. So again, it's menu, analyze, regression, show linear mx plus b. So there's our trend line and the equation for the trend line. So let's go back and write down the equation. The equation is y equals 1411.43. I'm going to round it to the nearest 100 times x minus 2,007.3060. Okay, let's just make sure that's right. So it's minus 27, okay, so it's 057.14. Okay, so now if we're going to predict what the price will be in 2020, we're going to put 2020, the year, in for X. And then we just have to calculate that. So we can go back to the calculator. And we'll just get a calculator screen for this. So we have 411.43 times 2020 minus okay, so we would predict the median price to be $138,031. Okay, so we did the scatter plot, we found the trend line, we found the equation, and then we used that equation to predict what the median price would be in the year 2020. Okay, we have a similar problem here with median home prices in California. I'm going to let you guys try that one on your own and see if you can come up with an equation and a prediction. And you could check your answers with me at a later time. Let's talk about the correlation coefficient. The R value indicates the strength of the correlation. So we can get this value on the calculator, and I'll show that in a second. But the closer that number is to 1 or -1, depending on whether the correlation is positive or negative, the more closely the data resembles a line and the more accurate the model is likely to be. So you have a reliable model if the R value is very close to 1 or -1. And the further away it is from that, the model is a lot weaker. If we go back and let's take a look at this. We had the data entered for the median home prices. What you could do now, let's go back and we'll get that calculator screen again. So here's how you get that R value. If you hit menu and statistics. You want stat calculations. And then you're going to do number 3, linear regression MX plus B. It's going to ask you for your column headings. So our column headings were X and Y. And then I'm just going to tab down to OK. And here's our information. So you can see M and B, the slope and the y-intercept for the equation, are just what we had in the equation that we wrote before. Right down here is the R value that we're talking about. So this one, if you look at it, is 0.982 if we round it to 3 decimal places. And I would say that's pretty close to 1. So this one has a strong correlation, a strong positive correlation. So we could say that this model is pretty reliable and that it resembles the data in the table. So that's what we're talking about when we talk about the correlation coefficient and the value of R. Okay, here's another table of values. It's the average cost of milk for several years. Table shows the data, year, and average cost. So based on the linear model, how much would you expect to pay for a gallon of whole milk in 2020? So again, it's entering the data into the calculator, getting the scatter plot, putting the trend line in, and that will give you the equation. Then you'll be able to figure out what the price might be in 2020 by using that equation to make that prediction. So we'll do this one, and then I'll leave another one for you to do on your own. But we need a calculator again. So I'm just going to get rid of this stuff that we're done with. And start again with a list and spreadsheet page. Okay, so again, X up on top of the left column, Y on the right. And the years are 1998, 2000, 2002, 2004, 2006, and 2008. The prices, $265, $289, $3, $301, $320, and $377. Okay, review them, make sure everything is entered okay. Looks good. So we're going to get the scatter plot. So we'll go back to the home screen, data and statistics page. We'll put our variables in, X and Y. So it looks like we have a positive correlation so far. Let's get the trend line in, analyze, regression, show linear MX plus B. There we go. So we've got a trend line. We have an equation. Just by the look of it, it looks like it's a strong positive correlation, but we're going to get that R value and take a look at it. We can do that real quick now. So let's get a calculator page. Again, menu, statistics, stat calculations. We're doing a linear regression MX plus B. Column headings go in. Tab to OK. And there we go. So we could see if we rounded it to 2 decimal places, the R value or the correlation coefficient is 0.92. So it is a strong correlation, and we could tell that from looking at the scatter plot before, where the dots were very close to the line. But let's go back here now, and we'll put that equation in. And here we go. So the equation we came up with, y equals 0.093429x minus 184.051. Let's go back, just make sure. Yep, okay. So there's our equation. They want to know what would it cost in 2020. So we have y equals 0.093429 times 2020 minus 184.051. So we calculate that, and comes up to about $4.68 would be the cost we would predict for the year 2020. And also, we'll just jot this on the side here, correlation coefficient R was equal to 0.92, which also told us that it was a strong positive correlation. All right, so here's a similar problem, and I'm gonna let you guys do this on your own, try it out on the calculator, and you could check your answer with me at a later time. And I will also leave you with these to work on your own, and come back to me and check your answers. Good luck, guys.